So I'm Bill Whitledge, and I'm going to be speaking about analysis apps for the operational tester. There we go. Okay. Since 2012, I have worked at IDA on test and evaluation projects, primarily actually for Department of Homeland Security. And they have a fairly similar acquisition process to the DoD, but there are a few differences. Primarily, their Office of Test and Evaluation is a little bit different than the DoD Director of Operational Test and Evaluation, but they still write test plans. In fact, we write test plans for them. They still collect operational data. And this briefing is going to describe four tools that I wrote to address common questions we have in operational testing and try to answer those questions. These tools are web-based, and they're currently available on our testscience.org website. So they are free, they're publicly available, and anybody can use them. There are sort of a number of recurring research questions we have in operational testing, and four of those are human factors, which we sometimes measure with surveys, particularly Likert scale surveys, which typically there's a question or a statement and you respond, strongly agree, disagree, and you can make those responses numeric. We often look at system usability, which can often be measured using the system usability scale, which is a particular type of survey that uses Likert type responses and computes a score that assesses the usability of a system on a scale of 0 to 100. We often look at probability of success, such as does a radar detect an enemy aircraft? Does a bomb hit or miss the target? Is the mission successful or not successful? And we often look at reliability of system components, particularly how long does it take for a component to fail or break after a specific amount of usage time or maybe a specific number of miles driven, et cetera, et cetera. So one way to answer these questions in a repeatable manner is to use certain tailored tailored applications. And if those applications can be web-based and more available to people, so much the better. So the four tools that I wrote, I used the RShiny package and a couple of other packages. And they are all, as I said, up on the Test Science website. Under the tools page, there's actually about 30 or so tools available through our Test Science website. And they're all very useful, but I'm going to be talking about four of them today. You can check it out later. The four I'm going to talk about today are thus the survey exploratory data analysis tool, the system usability scale tool, logistic regression, and parametric reliability models. And as I said, there are about 30 of these, and you don't have to know anything about coding. All you have to do is have a reasonably simple data set and have an internet connection, and you can upload your data and you can produce charts and tables that can help you with a briefing or a report or just further analysis. So I'll talk about the Likert scale survey responses first. This app you can upload a data set where each row is one survey response with a bunch of questions as comments. And from that, you can produce histograms, bar charts, and box plots of all your survey responses. The data you see here is notional, so it's not any particular program data, but so it looks fairly evenly or uniformly distributed. But if you have real survey data, you can pop it into this tool as long as you have it in a simple Excel table or CSV file, and it'll quickly produce these graphs, which are downloadable and can be put into any report or briefing. So that's that one. The second tool is the system usability scale, and it is fairly similar to the previous tool, but it is specifically designed to compute the system usability score, which again is a score on 0 to 100 based on 10 survey questions. And it actually allows you to analyze those scores according to different covariates. So if you have in your data set, say, someone's number of years of experience, or their rank in the military, or their job title, whether they're a researcher or an operator, or their department, I mean, whatever you like. Sorry, these aren't advancing. There we go. Yep. So it allows you to graph the distributions of those scores, and you can actually make box plots of those scores. Again, all downloadable for your reports or your briefings. Okay, time's flying. Estimate the probability of an event occurring. So this is what I talked about. If you have a success or failure, we typically call that a binary variable, but we'll often use a logistic regression to model that. And you can model it in one dimension if you have a single continuous covariate. Perhaps like in a cyber example, maybe age of a cyber indicator you might think that would influence the likelihood that it would detect something, or perhaps distance driven might influence the likelihood that something would break. But anytime you have a yes/no variable, you can, with a continuous covariate, you can model it using this application. It also does the two-dimensional case. So if you have two continuous covariates, you can actually plot a heat map that shows the probability of an event occurring based on two continuous covariates. And we'll actually do a generalized linear model of a polynomial term. I think it goes up to the fourth power, but probably never need to use that. And then one more. So the reliability application models three different parametric distributions, the exponential, the Weibull, and the log normal, which are common long tail distributions that we sometimes use to model data that might be of the form time to failure. So if you have a bunch of vehicles, for example, at a test, and you drive them all a certain number of hours, and you record when each one breaks, and maybe some of them don't break, but typically you'll get tail with sort of a long tail distribution. A few might break up front, a few might never break, and you can plot these reliability curves for them. And you can actually compare the models using this application over time here. So, and allow you to output some reliability plots, which are sort of colorful, and you can put in your briefings or your reports. So again, you can use these 4 apps to answer common research questions in operational testing. There's certainly no substitute for your own research and own analysis, but they might be a good starting point if you have these types of metrics in your operational test plan. Why use the tools presented here? They do provide good reproducibility of results. If you have the same data set, it's relatively quick to make the same plots over and over, faster analysis of new similar data. If you have a new data set of the same type, standard and more beautiful aesthetics and figures, there's a lot of customization you can do within the apps to change the look of your plots. Easier data uploads, smaller workloads, pretty web accessible. I see Denise coming over here. These apps are available, as I said. They're available publicly for use, and for IDA researchers, they are available. The code is actually available for download at our internal repository. So use test science software tools to improve the efficiency, aesthetics, and reproducibility of your analysis. Just bring your own web browser and simple text data files. Most importantly, after analyzing the data you have, say what you know and what you think as directly and succinctly as possible, or else no one will listen or care about your figures. And special thanks to all the reviewers that have reviewed these apps. They actually took quite a while to get up and running and publish to our website. So thank you.